Today we are going to be talking about two more behaviors of waves. One is specific to light, and the other can happen with any wave. So diffraction is the one that applies to any wave, so we'll start there, and polarization applies only to light. Our objective is to be able to identify the properties of diffraction and polarization. So, diffraction is the bending of a wave around or through a barrier. The diffracted wave will have the same wavelength as the original wave. So, when you look at diagrams like this, this is a crest, and this is a crest, and this is one wavelength. And actually, it depends on the picture, but there'll usually be a key. Sometimes this is a trough and a trough, but the point is that from one solid line to the next, that is a wavelength. And if you notice, the wavelength stays the same as it goes through this barrier. Diffraction will work best if the opening is about the size of that wavelength. So this picture is a little bit off, but it's about the same. It's not super tiny and it's not super big. So it has to be about the order of magnitude on the same scale. So sound can diffract around a door while light cannot. That means if you think about it, if someone is outside the door and they're before the door frame, but they're talking, you can still hear them. Even so, the sound wave is bending around that opening because sound waves are huge. And that means that that's why you're able to hear a sound wave, even though it isn't going directly through the opening of the door. So diffraction applies to any wave, but not to particles. So this is an example that shows that light acts as a wave because light does diffract as well. But other things like BB guns, as you can see in the example here, it's not going to turn the corner, no matter how cool Salt was. If you saw that movie, the bullets don't bend like that. You have to look that up if you haven't watched it. Anyway, so this here is an opening in like where the ocean is. So there's a small opening here and here, and these are regular waves, just ocean waves, and they're going approximately in a straight line, and they're going to go through this barrier, and when they get here, they bend. Now, diffraction can happen so that there can be more than one opening, and they will bend and they can overlap. So this actually comes in handy for light for some really cool physics stuff. Like that's what we can do to examine things with X-rays. It's called X-ray diffraction, and we can actually look at the insides of things and figure out the crystal structure of minerals and other things. So diffraction is actually something that's super useful. But anyway, this is where you would see it like on an everyday basis, just out on the ocean where you have an opening here. So the next thing, so this is still diffraction right here. It says when a wave enters a new medium, it will travel at a new speed. So it keeps the same frequency. The frequency does not change. Frequency determines the colors of the visible spectrum, and it just doesn't change. So the frequency stays the same. So it means that if it's going to go from a fast medium to a slow one, say you're walking in air and then you hit mud and mud slows you down, then the waves spread out if it goes from slow to fast, the waves spread out as they get faster. If it goes from fast to slow, the waves will get smaller. Okay, so this is just showing that it's going slow, and then it hits this medium, and then it goes faster. You can see they're closer together. So the wavelength is closer together when it hits the new medium here. So polarization, this is only light. So we have light, and it's in all sorts of different directions. That's what this is here. And these are light rays. So then you have a polarization. You have a you can take polarized glasses, and they make it so that it's kind of like this, so that any light that is not straight up and down, it'll get rid of this one and this one and this one and this one and this one, and then only this can actually fit through this hole. So there's lots of these rays around in everyday life. So then that means that it has screened out everything except for those that are oriented in the same direction. And if you take two polarized glasses that are polarized in different directions, it will block out all the light. And this only applies to transverse waves. In our case, usually light for our examples.